Hello everyone. In this video, I am going to demonstrate question number 5 and question number 6 in the Christmas break problem set. And they are actually the questions that have 3 stars out of 4 stars, so they should be fairly challenging, but not that hard for all of you. So let's start. For question number 5, I asked for the smallest integer of x, which is greater than 1, which the x uh, which the square root x, square root x, square root x, this thing is the integer. Well, if this is an integer, like we would first do some conversions. When you're having the square root, it is fair if you have x squared, you turn it into x to the 1/2 power. And this also applies for this situation. When you have x, like the whole thing, when converting all the things into parentheses of x to the 1/2 power, you will get this one. When you're having this equation, you just need to combine each term together. When you have x to the first power times x to the 1/2 power, you're actually adding up the power. So you will just get x to the 3/2 power, 3 to 3 over 2's power. So after this, you also have to have it being having to the power of 1/2. When you are having the something's power to the other's power, you are actually multiplying them together. So for this one, you get x to the 3/4 as a result. And when you're multiplying it by another x here, you just plus 1 for its power. So you have 7/4 x to the 7/4 power, and having another 1/2, you will just get x to the 7/8 power. So like after you are having this one, it's fair for you to just convert it back into this form. So like when you're having the 7 inside, you do not really need to care about 7. Like it does not matter if like this is an integer or not, if it's another number, but as long as it's an all number, that doesn't really matters. So what matters is here out for 8. When you have something like something to the 7th power, but is still like a integer after this conversion. So that means the x itself should also be something's 8th power. So as it said that x is an integer greater than 1, so then x should be 2. We have 2 to the 8th power. That gives you the number of 256. So x here would be 256. So the answer is 256. For question number 6, it's actually like a little bit about binomial theorem, and I feel like you might be heard of it if you haven't just like looked for this theorem or asked your math teacher about it. So actually, like when it's having root 2 minus 1 to the 5th power, you are just expanding this out. And I would prefer to do it in the way of the Pascal's triangle. We're having 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. So this is actually what the coefficients are for something that is raised to the 5th power. When you're expanding this, you have root 2 minus 1 to the 5th power. So that is the first term, and this is the second term. Like actually, it's super nice that I have -1 here, -1 here. So what really matters for this term, it's actually if it's plus or minus. So when -1 is raised to a even power, it's going to be +1. And when it's raised to an odd power, it's actually going to be -1. So after this, you just need to like expand this out with the coefficients that come from here. And after you just got some straightforward calculations, you will just get 29 root 2 minus 41. As is asking in the form of root k plus 1 minus root k. So you need to get 29 inside it. So when you're getting something outside a square root into the square root, you just need to take a square of it. So you have 2 multiplied by 29 square, and this would be root 41 squared. Uh, so so when you are actually doing the calculation of 29 squared times 2, that's 106, 1682. And for 41 squared, that's 1681. As it's having k plus 1 at first and k at later, so you will turn this into root 1681 plus 1 minus root 1681. So the final answer would be 1681. Yeah, that's for all the questions.